Hey there, everyone. I got something a little bit different here in front of me than usual. Um, Obviously, this isn't, I guess, automotive like my content usually is, but for a few years now, I've been starting to get into radios, collecting the darn things, tube radios more specifically, but just any old radios in general. And I've restored several. I don't know, about 7 before this. And well, then I kind of hadn't done anything in the last year and a half, and this last month I just restored 3 here, and I'll show in just a sec. But I think I'd like to, I guess, do a video on doing a radio. This is one of them. I'll probably do videos on a couple of them that I'll do here. This is a 1952 Traveler. Unfortunately, the Telechron clock isn't working. Usually these things always work, so I'm hoping it's just stuck rotor. Although these are easy to replace if I have to replace it, but it could be a power issue. You never know. I did plug this radio in. You're not supposed to plug in. Okay, the general rule of thumb is you shouldn't plug in old tube. Well, even it could be in solid state. You really shouldn't be plugging them in because the electrolytics and the capacitors, the wax capacitors, paper capacitors, could be plastic coated too, but they're going to be shot. They're going to be absolutely shot. But on these little tabletop sets that don't have a transformer in them, there's really not much that can go wrong. Basically, pretty much the worst thing you could have happen is one of the old caps explodes or something like that, but you're replacing the darn things anyway. So you're not, realistically, you can plug these in. I mean, you shouldn't, but do what you want to do. Let's just put it that way. I'm not telling you what you should or shouldn't do. You should have a variac and a dim bulb tester, and I have neither of them. So there's that. Well, anyways, I plugged this in. Like I say, clock doesn't work. Actually, when it started coming to, because it takes 10-15 seconds. I was actually surprised how sensitive this was because I was tuning stations and it was really picking up really well. I was thinking it was a 6-tube set, but it's just a 5-tube set. But still a really sensitive set. It was playing just fine for about the first 10-15 seconds. Then it was starting to all get garbly and weird, and so I shut it off right away and it squealed at me. And I guarantee you there's some, either the electrolytics are shot, or there's probably a melted wax capacitor too, or something like that under the hood. At least more than likely. So anyways, so not only do I restore these back to working condition, I also add an auxiliary input to these things, so that way I can connect. You can either connect a device such as an older cell phone or a laptop or iPad or whatever, tablet, directly, or you connect a Bluetooth puck like this, and then you can just Bluetooth from your phone, your laptop, your tablet, whatever. So that makes these radios more usable because there's literally nothing to listen to on AM, and where I live, virtually nothing comes in anyway. So yeah, yeah, I guess as an introduction to this, like I say, this is something I'd like to do at least a few videos of, and if people like it, I'll do more of them. So I'll just quick show a few radios that I just did. Actually, I did 3 of them this last month, and they turned out pretty nice. So I got the chassis out of this. I wish I could get the clock out. I mean, if I have to desolder it, I will, but there's plenty of room to work on it with it left like that. Anyways, back to the radio itself. Well, a couple things I need to notice. One, this has been replaced. That's not the original, which is half the reason why it still probably works. Well, I mean, that's literally the reason why it still works. This disc capacitor is definitely not original. You can tell it's been soldered on there. Somebody hit the wire. I mean, it should be fine, but it's kind of ugly looking. The bases are it's been moved around a lot. I'd rather see a fresh yellow capacitor matching the rest of them, so I'll probably replace that. It does have a little couplet in it. That's definitely original. It's got a single mica here, which is listed. I see why when I fired it up after 10 seconds or so, 15 seconds, it started acting crazy and then did that squeal when I shut it off. These two capacitors, and more specifically, especially the one below it, is completely just melted. This one is too, but the other one really bad. In fact, these are welded together. I tried moving this resistor, and I couldn't because it's stuck on. I'm not going to pry it too hard, but not only that, but you got 1 and 2 resistors that are all covered in melted wax as well. So you got 2 resistors and 2 capacitors in one giant mass of wax. So yeah, that's a no-go. So that little disc capacitor is a 005. This one, that one, and this one are 05s, and that one there's a 0.1. And according to the schematic, this is supposed to be 250 microfarads at whatever, it doesn't matter. Yeah. Anyways, so yeah. One thing to note, I got a schematic here. It's not very good. This is very small, and you can't read all the numbers, so it's kind of difficult to tell some of the resistors and capacitors. There's a few things that kind of, one that they don't even mention it. Like, it only shows, not including the volume pot, 9 resistors, but I'm like, there's way more than 9 resistors in this thing. In fact, actually, I counted multiple times. I got 13, but then when you look at the schematic, it shows that there's definitely more. However, still one short. The schematic shows 12, as far as I'm aware. Unless, even though that's the volume pot, I believe right there, that it still counts the resistor that's attached to it or something. I don't know. Well, anyways, so but yeah, it doesn't. So my guess is a couple of these are the same resistors, but they don't say like, oh, this resistor times 2. Same thing with the capacitors. You got the 0.05, which has been turned into a disc capacitor. Yeah, right here. See, it says PC, which I'm assuming stands for paper capacitor, because this is electrolytic capacitor, and the MC is mica capacitor, even though the couplet is, would be ceramic, just like that disc capacitor. But they just probably didn't refer to it as that back then. Well, okay, to be fair, never mind, I'm retarded. The capacitor inside is mica, just like inside that molded capacitor is mica. The body itself isn't mica, so never mind. Forget I said anything. So that is right. So anyways, you got these 4 up here, or no, 3, because the one is the that mica. I was like, so same thing. You got 4 other paper capacitors, and we're missing one on the parts list. So one of these, obviously, because 2 of them are probably the same or whatever. So yeah, that's kind of silly they do it that way. I'm sure maybe other radios do it, or diagram drawers or whatever did the same thing, but most of them, don't do that. They list every single one. So just to keep that in mind. So the next step is to, 1, test the tubes, just see how they are. But also test the resistors, see which ones are out of spec. These carbon ones, especially if this stuff here got fried, chances are there's going to be at least a couple resistors that are out of spec. Especially the ones that are, even when stuff's not fried, just the ones that are coming off of the electrolytics, the rectifier, or the output tubes especially, chances are they're out of spec too. So check all the resistors. I'm going to scrape the wax off of them too, just to see what the hell they even are. Scrape the wax off them, test them all, test the tubes, and then I can go ahead and make my parts list, which will include, obviously, these 4 capacitors. Like I say, I'm probably just going to replace that disc with a Mylar, just so, they all match. And that way I don't have to worry about that goofy, kind of ugly looking anyways. And then, of course, obviously, the 250 microfarad, which obviously they don't sell 50s anymore, just get 247s. Yeah, and then, then the first step will be to, well, I'm probably just going to go ahead and replace all. Usually I just replace the electrolytics. Since I know the radio works already, obviously I'm not even going to bother testing it once I replace it. I am going to replace, at least get these two caps replaced first. Then I'll test it out. That way you can test it out for more than, say, 10-15 seconds before it starts to burn itself up. So, alright, so I will test the tubes next and go from there. So this is my first real testing after I replaced the resistors and the capacitor in my tester. It worked pretty decent before, but wanted to put new ones. Anyways, this ugly looking C50C5. So that's fine. Short. They're supposed to be short there, there, and there, which is fine. No, no, and no. Was acting a little funky when I first tried it, but now it seems to be sorted out. It's a little on the weaker side, but it's still good enough. I'm not going to change it out. And then gas test, of course, they almost never fail gas test. So first one is good to go. Okay, you got 35W4 on here, which is an original Travler. 4 and 6 are shorts, so short, no, no, no. It's okay if it flickers. There's no gas test on this, but yeah, reads pretty good. So on to the next. Had a little bit of scare on this 12AV6, which also is another original tube. Wasn't testing right, and I don't know what I did wrong. The 12AV6 isn't even listed on this chart. I actually have to go to the booklet, and so I didn't realize at the time. I don't know how I messed it up, and it just wasn't testing right. 7 was, well, it just wasn't right, and I was gonna call it quits, and then I thought, gosh, let me look at it again, and I was like, I don't think I tested it right. I want to double check, and so I don't know if I was panicking or what. I went back to the previous tube setting, which was the 35W4. So when I set it up, not only was it not testing right, the thing was glowing like a Christmas tree light. I'm like, something's not right here. I'm like, oh my God, I'm frying the poor thing. So recollected myself, realized that 1286 is not on here. I forgot about that. So I open up the booklet. Here's the first test right at the top here. This one has 3 tests. 4 is a short, 1 down is the gas test. But anyways, A4 is short, the rest, nothing. Pull the trigger, good. Drop down for gas test, good. So, all right. And then, because I thought maybe all I did was change the resistors and 1 capacitor in this tester, and I did 1 at a time. It was like, I thought, man, did I wire something up wrong? Even though you're not doing any wiring, you're just replacing resistors. And then just an FYI, I had to replace this meter when I first got it because the meter was shot. And trying to find a replacement original one is almost impossible. It took me months to find this one. It's just that it doesn't have the scale for the gas test, which was down here. The gas test is opposite of the emissions test. So, yeah. That's why I had that written on there like that. So, anyways, after that little scare, on to the next. Well, I guess I do got to record the second test. So this is the second test, so I got to readjust the settings and whatnot. Pass the shorts test, same as that doesn't change. Well, it really shouldn't change no matter what test you're doing. But yeah. And if here's a good 12AV6 that I know is good. Put this on. Might take a few seconds to warm up again. But yeah. Now again, that might not be the end of the world because, well, I mean, you should have all your tests be good, but on a lot of tubes, the first test is really important one and the most important one, but I'll try the next test, see what it does. So yeah, here's the third test. It's fully warmed up. Take out the Travler and put this, whatever this one is, in. Fire it back up. Again, it might take a few seconds to warm up. There we go. So, I don't know. I'll probably keep this in for now. If it runs fine with it, it'll be okay. Usually on the most of your tubes, the first test, like I say, is obviously the one that has to pass. The other two tests, obviously, it's ideal if it's in the green, but it's not necessarily the end of the world if they're not, because obviously it still works. It still worked with it, but we'll see. I may replace it, once I'm done restoring the radio. But so, anyways, on to the next tube. Here's the 12BE6. It has two tests. Passed all the shorts just fine. It's halfway decent, It's getting a little better now that it's warmed up even more. So that's adequate. And the other test, let's see. Crank up the volume, 2 volts, woohoo. And just 6. Put the 5 down. So, oh yeah, she's really good on that test. She pegs the meter. So, and then, just to go back up, bring that one down. Yeah, it passes the gas test. So, yeah, that was pretty good. So, on to the next one, last one. And the 12BA6 is the best of the bunch. She pegs the meter. So, yeah, and then for, let's see, the gas test. Yay, it pegs the meter the other direction. I mean, most tubes, it's rare for a tube to pass, emissions test and not pass the gas test. Usually it's either they got gas or they've gone to air. It's kind of almost no in-betweensies. But, so, yeah, so with the exception of the one that failed that one test, like what was it, the BE or AV6 or whatever, like I say, that one will be fine for now. So more than enough to get the radio up and running, fully restored. So anyways, on to checking resistors. Okay, next up was I went through and tested all these resistors here. I guess, especially on this video here being the first, I'll just, for those who don't know, I'll explain a little bit. These are tubular carbon resistors. These are pretty much all you're going to see in 40s, 50s, through the early 60s. So it's going to be the most common. There's two other styles you'll typically see as well. On your 20s and 30s sets, you'll see what are people call dog bone resistors because they look like dog bones. They're also just carbon. And then towards the end of the tube era, some of your radios started switching over to tubular ceramic, which is still in use to this day. And them resistors there, you pretty much never have to worry about. They're either they're good or they're burned out. There's pretty much no in between. Whereas your old carbon resistors, whether it's dog bone style or these tubular style, they don't drift inherently by themselves like old wax capacitors and electrolytics will. But when they're exposed to abnormal amounts of electricity, which happens, especially the higher power resistors, such as ones coming off your output tube, your rectifier tube, your electrolytics, your volume pot, stuff like that. When tubes start to short, or when they short, say the electrolytics or these caps or whatever, any amount of abnormal amount of load for any length of time is going to throw these out of whack. Whether it's a lot or little, obviously depends on how bad it's been hit. But I make a good habit, especially in these tabletop sets. I just check all of them. Now, like a lot of these over here in the frequency section, they're generally never going to be bad. In fact, actually, I got all the readings here. I got 13 total resistors that I counted, which this schematic I got is terrible. The way this parts list, I don't like. Most parts lists will show each individual component, regardless of if there's multiples of them. It took me a few minutes to figure this out because I'm like, there's way more resistors in here than what this parts list is showing. And because each of these got their own number, so they just reuse, well, they can't hardly read half these numbers anyways. They just saw it, it's terrible. And actually, I'm only seeing 12 in the schematic, and there's definitely 13 in this radio. So there might be something else going funky on this too. I'm not sure. Same thing with the capacitors. There's one extra capacitor in here than what shows on the parts list. Again, because two of them are the same value. So anyways, back. So I make it happen to just test them all just to be on the safe side. But like I say, I'll go back to here. Actually being in circuit sometimes, especially these really high value, like resistors are just like golf. The higher the number, the smaller they are. Just an FYI. But actually, these being in circuit, they actually underread. Like if I cut these out, or at least cut one lead and measured it, it would be closer to these. It will be a little over. But all the ones that, like I say, come off the tube, the output rectifier, the electrolytics, and the volume pot, pretty much all of them are out of tolerance. Now, when reading these, if they got a silver band, this is actually the only one. This one here, which is much bigger than the rest. This is a 1 watt resistor. The rest of these are half watters. This is the only one with the silver band. That means it has a 10. Is it? Yeah, 10%. It could be 10% out of tolerance. If it was gold, it'd be 5%. And the rest of these don't have any band, extra band, meaning they can go up to 20%. And actually on this, most of these are not terribly out of spec. A couple of these really high value ones are, but they're more power resistors. You can get away with being quite a bit out of spec, and it'll be fine. But it's just good practice just to replace them, because this one's, nearly 3 times over. That one's nearly double. These are over double. This 330 ohm resistor here, that's the one. I don't see it. It's not on the parts list whatsoever. There's 3.3 million, and then you got 33s. There's 3 33s actually. I count. Yeah, there's 3 33s in here, but this 330 I don't see on the schematic whatsoever. That's the extra one that don't make sense, but whatever. And then this 3.3 million I can't even read because I got a automotive style voltage tester and it only goes to 2 million. But that's fine. So anyways, that's kind of low down. These are oftentimes hit hard. These, and another thing, on your fancier tabletop sets as well as consoles and whatnot, this resistor, it might not be the same as the rest. It might look like a giant white ceramic. I mean, that's what it'd be. It could be a giant white ceramic resistor, or it could be a tubular ceramic resistor that's wire wound. It can be a metal enclosed, riveted to the chassis. It'd be riveted to the chassis, but it'd be enclosed in metal. Called a candome resistor. Your smaller sets will have it'll be just a single resistor, but there could be 3, 4, 5, even 6, I think, sections to a candome resistor, and each section is a different resistor, so you got to check all of them, and one could be burned out, or 2 could be burned out, or way out of tolerance, so you got to clip in a new resistor just for them. You don't have to replace necessarily them all. And then on some of your really older radios, it look like a stick with sand covering it, and they call them, a sand resistor. But again, that'll be usually this. But on these smaller tabletop sets, it's usually just a 1 watt carbon resistor. Like I say, your bigger ones are going to be like 5 watt, 5 to 10 watt tops usually. So anyways, that's probably about it. Don't want to run on too long, but yeah, like these definitely affected, especially these 33s and that 330 that's why they're over double out of tolerance, because they got hot. You know, they didn't get crispy. You know, I've seen plenty of these where these are just, where they're absolutely black. And actually, I had one that I just worked on. It actually didn't even have the original resistor. Instead of having this, it had a older style dog bone resistor, so it had already been replaced once, but that dog bone resistor was completely burnt in half. It wasn't burnt, the middle of it was gone, and you grab the ends and it just turned into chalky carbon. So I was like, wow. Then I had another one where it was the Crosley I did. It was pretty much all original. I can't remember what the electrolytic was replaced on. I can't remember. Not that it matters, but the only other component had all the original tubes. Everything else was just this resistor here, I believe. I believe it was just this one. Well, whatever. And that one there was a 40. It was supposed to be a 47 ohm, and someone replaced it with a tubular ceramic wire wound 100 ohm, which that's, I mean, for a power resistor, that's not the end of the world. But it wasn't marked at all, but it had to be like a 5 watt. It was like a little overkill. So I just put a 1 watt 47 back in it, and kept that 100 ohm resistor, because that's a good resistor for something else. But anyways, enough rambling on. Guess the next part will be to order components, now that I know the tubes are decent, with the exception of that one, like I said, was weak, but I'm going to leave it for now. But I'll order capacitors and resistors, and once that comes in, I can proceed to party. Finally, after about a month of waiting on parts, it was some isolation transformers that they come from overseas, so they take a while to get here. I finally got everything, and I separated all the components. So I got, being this is the first one of the bunch, I got everything here. I guess only two things to denote is that that 0.005, which I did order cap, but I'm not going to use it because turns out that little disc capacitor is original. I seen other pictures of others online, and they have that same disc capacitor, and so I'll leave it. The reason why I was going to replace it is because the OCD in me wanted them all to match, and still kind of does, but if it's original, I'm keeping it because it's going to be fine. And then I knew I had 33 ohm resistors because this needed 3 because they were all shot, and I did have them, but not that it makes any difference. But these are 1 watters instead of half watters. But to be fair, they probably should be 1 watt anyways, with how much power they handle. But otherwise, yeah, I got my 47.047 capacitors to replace the 0.05s, and yeah. So I'll get this torn back apart and start having at it. So I got that old capacitor, which is definitely not the original. This was kind of a bear, because usually these straps are aluminum, but that thing's steel. And so trying to get that out there without destroying anything was tough. But had I known it, you didn't know, I was kind of curious as to whether or not it was the original. But you see right there in the middle underneath that little wafer board, is the remnants of the original strap, and they just soldered that strap to the remnants of that strap, because I was just trying to wiggle it and break it free, and then all of a sudden it came apart where it did, and I saw all the solder joints. So, but anyways, so you got these two positives, which they're both the same. They're both 50, so you don't have to worry about mix them up. So I'll attach one end of the one capacitor to this. I got the other one, I got to solder it yet, but then I'll cut this, they'll share the same ground, so I'll just cut this down, probably down here somewhere, and after I twist these two, that one and that one together, I will, yeah, solder that and go on from there. So, see you in a sec. Got the two negatives twisted together. Make sure it's the striped ends, because that's your negative going to negative. Your non-striped is your positive. Got it just hanging here for the moment. Normally I would power it up now to test it out, but I knew it worked before, somewhat. But two, that really melted out capacitor I know was shorted bad, because like I say, it was, when I test fired it the first time before I started working on it, it wasn't happy, and I could tell it's from that blown up capacitor for obvious reasons. So I'll just go ahead and replace, I guess I might as well just do all 4 of them. And then test fire time. And then provided that's good, well then I'll do the resistors. Provided that's good, be just clean up and clean everything up and oil everything, and then probably, I'm not sure if I'll do the input next or if I'll do the clock first. Horse a piece, really, depending on what you do. So, anyways. Wow, that was a little more involved. This chassis is so small and so tight and so narrow. Everything's laid on top. There's a capacitor under there that I replaced. So I was just gonna normally try to just replace one component at a time. But I had to cut this capacitor out so I could even get to that capacitor. And holy moly. There's the one. Isn't that a beauty? And then there's that cutie pie. Jesus. Well, anyways, but then them 3 resistors that were on in between these two, I was like, well, crud, I can't. You know, I won't be able to replace these. Well, this one I probably could have, but these 2 here would have been, would have been a lot tough. Yeah, so I had to dig everything out, get that one replaced first, and then I did these 3 resistors, and I just got this sucker in. And man, like I say, it's a tight working space. So, but I got it. All I got left are these 2 capacitors here, then a couple resistors. Almost had a little bit of an I had ordered 100 ohm resistors, because that's what I thought was in here. I'm looking for sitting there looking around for a black, brown, black. I'm looking. I'm not seeing anything. Eventually, I see this. I guess it does look brown, black, brown if you're not paying attention to it too closely. But that's a brown, green, brown, which is 150, not 100. Luckily, though, I had some 150 ohm resistors in my stash of resistors, so crisis averted, even though it wasn't that big of a crisis. But yeah, so anyways, yeah, so on to the last, let's see, 1 2 3 4 5 resistors and 2 capacitors, and I'll be back. I still have 2 capacitors and 1 resistor left to go, but I figured now would be the time to see if any sparks happen or not, or if it actually works before I go any further, because normally I would have checked that a long time ago. Well, it's not blowing up yet, so that's a good thing. I'll mess with it for a second here.
I'm sure
there.
It was the mustard that made a difference. And it was at that time that I knew I needed to plot and plan my exit from law. And one day I found the National Mustard Museum, which I did. And it opened in, let's see, it would have been April of 1992.
Not too bad.
Growing ever since.
I mean, it's nighttime, so there's hardly anything for reception around here.
I think pieces of great mustard.
And my dingus self accidentally put a little hole in the speaker cone, so I'll have to fix that too.
Old mustard advertising.
But alright, that's success.
As you know, that mustard.
So I will replace the last 2 capacitors and that resistor. There, got it all buttoned up, got all that all taken care of. Yeah, this is not a friendly radio for a beginner. component-wise, it's easy, but that's a heck of a chassis. But anyways, there's the casualty pile. Bunch of resistors and capacitors and whatnot. So let's fire this sucker up. Well, so far so good. Nothing's blowing up again. Had to move a bunch of wires around and make sure things weren't contacting things.
And your antecedents, that's a geek word that means how you live your life. You know, for example, if you eat tuna fish 2-3 times a week, every week, but you like tuna fish.
And there we go. I like tuna fish, so I think this is a success so far. So on to, I believe I'll have to think about it overnight to decide whether or not I want to do the Bluetooth next or the clock next. So see you then when I decide. Well, I decided I couldn't wait, so I decided to tackle this now, or a little bit later anyways. Well, good news and bad news. Good news is that's not frozen. It spins freely and it's oily looking, which means that's actually kind of bad news because I'd rather had it been stuck, because unsticking it's the easy thing. I ran my meter across the two terminals and it's not reading anything as far as the ohm meter is concerned. So I'm wondering if that coil is bad, which is unusual because Telechron clock coils really never go bad, like never. So I'm gonna investigate it a little bit, probe around, pull the thing out maybe, check it over, and go from there. Yeah, something must have happened to this poor sucker. This side, there's a broken wire, and this side, underneath this tang here, this one here, there's a whole bunch of broken wires all underneath. They were underneath this roughly, because it would have sat like that. Well, yeah, about like that or something. So it got hot, like really hot, and melted a bunch of stuff. So I don't think, I see what I can do, but I don't know if I'll be able to fix this. Because if you take out too many windings, it's going to alter the time of the clock. It ain't going to keep correct time. So I may have to look for a coil, which that's not going to be cheap, unfortunately. Oh my God. I think I'll have to open this up to double check. I pulled this out of a dumpster a year and a half ago. And it's got a working Telechron clock in it. And I'll have to pull the back off just to be sure. But I think it's got the correct coil in it. Because I was looking on eBay, I couldn't really find nothing. And even what I could find was like, they were wanting like $50, $70 just for a parts unit. And it's like, no. I ain't sticking that kind of money. If this works, oh my goodness. I was going to do a video on this radio, get it working again. And I still may do that, but it won't be with its clock if it's got the right rotor. So, oh my God, I can't believe... I knew this worked, and I was like, oh, I wonder if it's got the right coil. Hopefully we'll find out in just a second. That's more or less the right movement. It's a slightly newer one, obviously, because this radio is newer. Really, the only difference is the... instead of using 4 screws to hold the steel pieces together, the top 2 are riveted, which is fine. It's still the same thing though. So, yeah, I will be cannibalizing it out of this one. Good. This is a weird design too. Look at the speakers on the back. That's so strange. Just for bonus content, I believe that is on. I can't remember if this thing worked or not. I'm assuming it's a giant buzz bomb. It's a GE. It works though. It's a buzz bomb, but if you replace some electrolytics, I guarantee you this will work. You think that's a little overkill? The one's supposed to be 30, and the other one's supposed to be 75. Well, I put a 33 and a 100. That'll work. There's only one wax cap in that sucker, but I'll leave that. So let's get some bonus footage going here and get the sucker plugged in. And as long as we don't smoke nothing. It's glowing. I got the volume like halfway turned up. Granted, it's nighttime, so might not get any good reception. Stop. Just needed this 12 BE6 was shot, so now she works. Although there's some type of interference, but that could be old cap still in it, or who knows. But it works. Now I can harvest the clock.
And not in a good way. That's why driving high is illegal everywhere. So.
Well, I got it in there and see if the transplant was successful. And well, I mean, all right, we're flipping the wires around. That I guess is to be expected now I think about it. This coil, it wouldn't fit in the way it fit in that clock. I had to flip it over, so I guess it makes sense that I'm gonna have to flip the wires around. Alright, flip the wires, so hopefully that'll take care of that little issue. Please, 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 please. Look at that! Working clock, and it's still going backwards. Fuck. Okay, how about the third time's the charm? Will that do it? Oh, thank God. It is moving in the correct direction. Okay, so when I went to go install it, it's kind of a pain in the ass, especially with it still in the cabinet. And when I first tried it, it was like not fitting at all. And so I flipped it over thinking, okay, as long as you flip the wires, should work. And well, obviously it didn't. That was a dumb on my part. But I tried it back the other way, and after a little bit of finagling, I got it to fit in the correct spot. And well, we got ourselves a clock. A working clock, to be specific. All thanks to that garbage find there. Oh, that is a huge, huge relief. Might as well keep this sucker too, because this is the original one. I didn't swap that out. Could have, I suppose, but no point. That one worked just fine. So, anyways, on to, well, audio input now. Holy crap. Fourth time's the charm. I ended up having to pull it back out again. Not because the clock wasn't working. The clock was still working, but it was vibrating really terrible. And it was only getting worse. And I was like, what in the world's going on here? And I think I had mentioned before that the new coil was, you know, obviously, even though it's the same, it's slightly different. And one thing was the upper connections were riveted together, whereas on the old one it was screwed together, bolted together. And I didn't think nothing of the time because I didn't see what it did, but there was this little little bracket right here that bolts to this, and at the time I didn't think it did nothing. Well, here it holds the thing for the alarm or whatever, setting the alarm or whatever. Oh, I don't have it. Oh, yeah, there you go. It's for the alarm. And so it was just sitting there buzzing because there was nothing holding it. It was like half engaged, basically. Or just flopping around and so on and whatnot. So it's like, okay, I'll just grind or drill out the head of the rivet and pound it out. You'd think it'd be that easy. No. I eventually got the head of the rivet drilled out, but trying to pound it out, and I was trying to be careful. I wasn't hitting it too hard, but here all of a sudden I realized that entire steel, what is there, 6 plates there? They were all bending. The whole thing was warping. I was like, oh my God. And then it was like, you're putting a ton of stress on the coil, and I thought for sure I would have broke the coil or something. Or anyways, after struggling and having to be very careful trying to get the iron bar separated from the, I guess would you say the left side? I guess you're facing this direction. It took a lot, and you had to be just super careful because it wouldn't take much to just absolutely annihilate that coil. And it took me, oh my gosh, half hour to get that apart. And so then I put it back together. I had to straighten out the iron first. The core, I had to straighten it all out. The center part was twisted and the left side was bent. And so I had to get it back to as close as possible. And well, anyways, I got it back together. It seems to be working. Still working. And it's silent now. So keep that in mind. If it's got an alarm like that, it's gonna need that little tab. So I would say if I had to do that again, I'd have to devise some type of a little press. Just to press instead of trying to hit the rivet out, the remains of it. Either that or try to drill it out all the way. I think a little press. I don't know. If I ever have to do it again, I'll know in advance. But so yeah, that was a little scary moment there because I thought I just destroyed the coil when I started bending stuff. I was like, oh no. But I took my time from that point on. Well, I mean, I was taking my time before, but I was making sure I was super duper careful, and I think I got her. So now I can move on to audio input. Here we go. I got all the components, with the except, well, actually, even though I've got some wire here, need a little bit of wire to connect everything. I got all the components for the audio input. I got my isolation transformer. Normally I'd have a 110 12 volt, but I can only get at the time 110.9. As long as it's between 12 and 6 volts, it could be 6, 7.5, 9, 12. That'll work. Same thing if you're in a European country or anywhere that uses 220. As long as the output is, between 6 to 12, that's fine. Then you'll need a 002 capacitor, a pair of 100 ohm resistors, a 270k resistor, a switch, which with these switches, for me personally, when you look at any old equipment from electrical equipment or whatever from the 30s, 40s, 50s, 60s, especially if it's a small unit piece of device like this, the toggle switches are really tiny, like really. Come on, focus. Are we gonna focus, or are we just gonna think about it? Well, anyways, they're really tiny, and a lot of them are like the toggle's like twice as long. And when you install it in the back of radio or the side of radio or whatever, it looks dorky. Not to mention, it can catch stuff if you're moving around. These are a little bit, because they're so small, they're a little bit harder to install in most cases. There might be some radios where the threaded shaft isn't wide enough, long enough in order to use it, which then fine, whatever. But I think it just looks better with the smaller one. It hides better. And then I got the cables. Oh, I just opened up the package. I'd ordered male cables because then you could cut them in half and you get 2 cables. And, well shit. Yeah. I mean, granted, the last set, I think I bought 5 cables for $15 and I cut them in half. And I got 10 cables and I was expecting to get 20 for the same price. And, well, guess not. I get back to 10 again. But so I'm not going to worry about it. I'm not going to. It was $15. Still getting 10 cables out of it. You're talking $1 and whatever that is, 20 cents a piece or 10 cents a piece, whatever. Anyways, so yeah, I'll basically show how I rig it up and whatnot once I get somewhat half together, and then I gotta figure out a place to install it. Normally it's not a problem. Usually I have a lot of space, so the capacitors will go here. It's tight, but I have to try to either shove it here or down in here somewhere. But it's I don't like it resting up against the tube sockets like that. But unless I can fit it in here, maybe I'll go in here. I'll figure it out. I'll have to just jam it in somewhere. Like I say, this is an unusually small chassis. It really is. I guess the only other thing I'm gonna quick mention about is when I had run it before, when I first got this radio running, I thought there was kind of an excessive amount of, I'd say, radio noise. But I was like, well, I chalked it up to 2 things. One, it was at night. And 2, the chassis, and more specifically, the tuner was really dirty. Had a lot of dirt between the fins, and that could cause issues. Well, anyways, I cleaned the chassis, cleaned and lubed the tuner and all that jazz. I also got this glued back down because it was just about falling off completely. I glued the crack that I put in the tear I put in the speaker. I got that all glued. Well, anyways, I ran the got it running, got everything clean, and then fired it up, and it's producing an excessive amount of radio noise. Now, it's not like a silver mica disease noise, like a static noise. It's like AM radio noise, except cranked up to 11. And like I got a couple really cheapo radios, a couple of them PC board radios that are in some cheapy solid state radios that can produce excessive amounts of AM noise, but this is even more than that. And so I'm not entirely sure what's going on. I will swap out tubes, even though they all tested fine, just because that's an easy check, of course. Otherwise, I wouldn't know what could possibly be causing that. I did peak the transformers, as well as the tuner, the main tuner section. Actually, that was turned down way too low. I turned that like 2 full turns or so, and it got much louder, but it didn't really fix that excessive AM noise. So there's only like one station, especially at night, that comes in strong or reasonably well. And sure, you could hear it, but there's just too much radio noise. So I will have to look into that. I would say worst case scenario, once I get this all buttoned up, taken care of, if I still haven't figured out after just swapping the tubes or looking into it, I'll call it a day I'll call it good enough for the time being. Because at the end of the day, again, most people are going to be running this with the Bluetooth, and not to mention if you're in a city or area where there's a bunch of really strong stations that may perform better. I don't know. I'm just kind of trying to cover my bases here. But like I say, I will try to make it so it's performing better before that happens. But if it doesn't happen within this video, just to let you know. Because otherwise everything else is running fine. So anyways, I will get some of the stuff soldered together, figure out a place where I'm going to put it, and get it back to you when I'm like, I don't know, about half installed, I'd say. So, all right. Okay, so I got things pretty much ready. I drilled a hole there in between the switch and the plug for this switch when it's inevitably installed. And then I drilled another hole for the cord to go through. And you got to make sure when you connect, in this particular case, since the cord is going through the chassis, you want to have it threaded through the hole as well as knotted. I can move this knot wherever I need to before you attach it to the isolation transformer. Otherwise, you're going to be, well, redoing a lot of stuff. Otherwise, you're going to be just redoing it. So you got your primary, secondary side. Primary side is this side, secondary is this side. Your right and left channels into 200 ohm resistors, and ground just goes to the other side. Here you have the 0022 capacitor, the 270K resistor, and that will go to the bottom or the top side of the volume pot, which is, this is the bottom side, this is the middle, and the other one in there, which will be, of course, the fun one to get to, is where I got to connect a wire from here to there. And then the wire that's going to it, which is carries the radio frequency, it's that white wire, that's got to be disconnected. And that will ultimately run to this switch. So the wire, I'll probably have to extend it because I doubt, if it reaches, great. If not, I'll have to extend it. But I'll go to one side or the other of the switch, and then the other wire will go back up to that lug, so that way you can turn it on and off. One thing to note, this is a two-way switch. So you make sure you don't solder here to here, one end to the other, because it will do, well, literally nothing. One wire's got to go to the center tap, and then you got to pick one or the other. I have to bend this over a little bit to make it easier to install the wires because the switch is pretty tiny, but it works. And then you also, the bottom side of the volume pot, you have to run just a single wire from here to that lug there. In fact, actually, just to test this, all I gotta do is I'm gonna glue this. I found a spot here to put it, but I had to cut this screw short so then it fit right in here, because otherwise it was in the way. This tube socket was in the way, and I didn't want it to be covering the tube socket. By cutting that screw short, it fits right in here, so that's where it's going to go. It's still tight. I don't like it, but you really don't have any other choice. So yeah, for testing purposes, you don't even need to have the switch even in the circuit. You just got to have the radio frequency disconnected, and then just have, like I say, connect there, connecting both sides to here, and that's it. So I will get this sucker super glued into place, and then I'll run wires back and forth to the volume pot, as well as disconnect that one wire, and then we'll give her a test. Well, I re-recorded this because I was using a original song that would probably get me copyrighted, so I'll use a alternative version that shouldn't get copyrighted. But anyways, got it in there and focus. I played it now for about, 15-20 minutes. Been playing pretty good. Sounds clear. No switching yet, but I'll add that here in just a little bit. But yeah, no, this is you got the connections there. So like I say, the one end will connect to the one end of the switch, and the other end will connect to that, and I'll be able to turn the radio back on. But yeah, it plays pretty good. Yeah. Anyways, on to the next part. We've got the switch installed in the back there. Disconnect that and switch the switch.
1947, I didn't realize it is Kim and the subject. And so Kim had, and by the way I got to her was through you. Yep. Because Chanel, her daughter.
Like I say, that AM radio noise, I don't know if that's just this radio. That just seems kind of excessive to me. But it could be. This wasn't, despite, the clock edition, this isn't a super duper expensive radio. This would have been, of the early 50s, this would have been considered a cheaper tabletop set, So that might be just the way it is. I guess if there's any veterans out there that knows otherwise, all I know is that switch back and pardon the phone drop. But at least on Bluetooth, again, it sounds really great. But yeah, the clock's still working. Just when you thought you were all done, I had all back together. I was just putting the knobs on when the dial was starting to slip, and then it jammed up, and I couldn't turn it in any direction. I'm like, what the heck? So I pulled it out, and I oiled the shaft back here, but it worked itself all the way through and jumped up the lip and got, come on, focus. Got the string all oily, which certainly not ideal, but still, I was like, what's the heck's going on here? What was happening was, when you turn the dial down all the way down, the cord wanders over a little bit just because of the way it works, but I suppose because it was oily and whatnot, it was, stop that, focus. And, okay, I guess we're just going to do that. And, it was pinching. There's a little groove here because it's not a super tight tolerance, just enough for the string to slip in there, and so that's why I was jamming up. So I had to pull the C-clip out to pull the shaft out to get it freed up, and I was messing with it for like 30 minutes or so, and finally I was looking at the spring here. It was not stretched out at all. It was on this tab here. It was, obviously when it was dry it was good enough, but with a little bit of lubrication it no longer was, and for whatever reason it was causing the string to walk over far enough. So I'm like, I gotta stretch this out. I wish there was another tab like in between, because I was like, that's a long to go from there to there, but I did. I got her, and well, now she's tight and no more slippage, and yeah, and it doesn't wander over far enough to pinch. So now I can put it back together, hopefully for the final time. Got it all buttoned up, all cleaned up. Clock is still working good. So yeah, I will say that the buzz, let me flip this cord. I'll flip it back. That alone cut the buzz down by 50%, and so I asked about that, and people online refer to it as modulation hum, and basically has nothing to do with I did to the radio. It is that a combination of this being, for the era, a cheap radio, cheap construction. Granted, it wasn't a problem then because AM stations didn't have the interference that they have today. So this would have came in probably crystal clear or near crystal clear, back in the 50s. But today with the lowered, reduced power that AM stations put out, as well as all the interference from, heck, my own electricity, neighbors' electricity, digital equipment, so on and whatnot, all that contributes. So one thing that can be done is they say if you add some safety caps between the power cord and chassis, that it could eliminate that. And I don't have any right now, and I guess I should have some anyways. And whenever I do order them, I could try it then. But for the time being, though, it's restored. It is what it is. So with that, I will transition to a little bit of Bluetooth here. But yeah, especially on Bluetooth, it sounds really good. And on that note, I could probably call this complete.